Loading screens. We all have our favourites. Some are short, some are long, some are beautiful, and some are… well, you tried, I guess? The point is, whether you like it or not, loading screens are an essential part of almost every video game. So, it's important to know what they're for and how you might want to go about making one. Let's imagine for a moment that our player is a member of the audience about to watch a stage show. The show starts in less than 5 minutes and none of the sets are on stage yet. So we need to get the set for the first act on stage before the show starts. You may choose to just start building the sets and have the audience watch the crew build the set and then watch all of the actors get into their starting position and awkwardly assemble before the lights go down and the show actually starts. Or you draw the curtain. With the curtain drawn, the crew can run around hectically before the show starts and the audience can experience a smooth start of show with no idea what was going on just seconds before that curtain was drawn. If you haven't gathered already, the curtain in this analogy represents a loading screen. So, let's take a look at how we can create our curtain. Hi there, I'm Matt and welcome to Game Dev Guide. In this video, we're going to take a look at how we can create a loading screen in Unity. We're going to look at how we might approach managing our scenes and also a few different ways we can use a loading screen to our advantage. I've got two scenes here, a super lightweight menu with just a few pieces of UI, and then an extremely detailed environment that I'd like to load into. The first thing we're actually going to do is start with a persistent scene. This is just an empty scene with a game object in it, and a mostly empty game manager script. This is going to act as a director for the states of the game and will, as the name suggests, persist between all of the different scene states and manage the logic for moving between them. So let's jump into the script and start our workflow. Below the singleton assignment, let's load straight into our title screen, as that's the first thing we'll want to see when the game starts. We want to load the scene additively, meaning that we want it to load in addition to our persistent scene. So we'll call scenemanager.loadSceneAsync and load our title screen with the additive load scene mode. Something I like to do when dealing with scenes is to create an enum with all my scene names in and build indexes assigned. This way I can easily reference their index and don't need to constantly check back and remember their names. I'm much less likely to change their build index than I am the scene name, and if I do change the build index, it's super easy to update. In the load game method, we'll write some pretty standard code for loading in our main scene. We'll want to unload the title screen and then additively load in our gameplay scenes. If we just hit play and try to load into it, you can see that we're sort of stuck in a weird state where we can see the old scene and there's no real feedback that we're loading into our environment. We also get this weird and frustrating no camera message from Unity. Overall, it's just a bit messy. This is the first case for why it's a good idea to have a loading screen in place. We can close the curtain and signpost to the player that their input did something, and now we're setting the stage for the next thing. So let's look at how to manage this. I've prepared a loading screen as a prefab here. It's pretty basic, just a nice background image, a little loading text, and a progress bar. In our game manager, let's create a reference to it and assign it in the inspector. Then, when we're loading our game, we can enable the game object. As you can tell, that already feels much better. We get almost instant feedback from clicking play, and our scenes start to load without us being able to see them loading in the background. The only problem is, when our scene is loaded and ready, our curtain doesn't draw, our loading screen doesn't go away. In our manager script, let's create a list of async operations called scenes loading. And let's add each of our load scene async methods into this list. We'll then create a new coroutine called getSceneLoadProgress and iterate through the list. While the scene hasn't finished loading, we'll yield null. Then at the end of our loop, we'll clear the scene's loading and set our loading screen to false. Now our loading screen will show, and when both scenes are fully loaded by Unity, our loading screen will be removed. This is a great place to start, but our progress bar isn't exactly very helpful in letting us know how much we've got left to go. So let's jump back into our manager script and start tracking progress. Let's create a reference to our progress bar in our game manager script. For each operation in our list, we'll total its current progress. Then, we'll divide our total by the number of scenes in our list and multiply the result by 100 to get its percentage for our progress bar. Now, when we load our scene, our progress bar gives us an indication of the total progress of all of our scenes loading. And that's the basics of handling a loading screen. As I'm sure you can tell, it feels a lot cleaner and a lot nicer putting up a screen like this as our scenes are managed in the background. So that's how we can manage progress from Unity's scene loading system. But usually most of us need to initialize some things and put things in place after our scene is loaded. For instance, I need my city to populate with pedestrians when the scene loads. If we just go to the scene as soon as it's ready, we end up seeing this. It takes a good number of seconds for the spawn script to start and finish, and for all of the agents to get moving. I'd like to avoid showing this initialization to the player, so we need some way of hooking the initialization of our scene into our loading screen. I'll create a singleton reference to the script I'm using to initialize my pedestrians, and add a float called progress. I'll also add a boolean to check if the progress is finished. Then we'll simply track the progress by dividing our count by the total number we're spawning. And after our spawn loop, we'll just wait half a second before flagging the process as done. This allows the agents enough time to start up. We could go through each agent and check individually, but it's cheaper and easier in this instance just to designate a small amount of time to wait. Back in our loading script, let's create a new coroutine called getTotalProgress. We'll use this coroutine to calculate the progress of both our scene loading and our initialization progress. We'll move our progress bar code into here too, and create a new float called TotalSpawnProgress. We'll create a while loop that repeats if our initialization script hasn't loaded yet, or if it isn't done. In here, we'll either set the spawn progress to 0 if our script is null, or get the progress directly from the script, and we'll multiply it by 100 to get the percent. Then, we'll calculate the total progress by adding our scene progress and our spawn progress, and dividing them by 2. Then, by assigning the result to the progress bar, we get the total result. Once the loop is complete, we can remove the loading screen. Now, our loading screen shows feedback for both our scene loads and initialization. By hooking these into coroutines like this, we can create feedback points for different stages. It can be traditional in loading screens to tell the player just exactly what's going on and what they're waiting for. So, with the extra information we now have, let's take this one step further and hook that into our loading text. Let's create a reference to our text field and assign it in the inspector. Then, in our script, let's format a string for when our scene is loading. And then, when we've moved on to loading our spawn progress, we'll show the progress in our text field. If we were to add more things to initialize in our scene, we could create an enum for each stage and assign the current stage in our initialization script. Our loading screen could then check what stage we're on and return a string and value depending on which stage we're at. So, that's more or less the basics of dealing with scene management and initialization progress. I could wrap it up here, but as you probably know, I'm never one to do things by half measures. If the player's going to be staring at a curtain regularly, you probably want to make that curtain as interesting or as helpful as possible. And there's a few simple things we can do to make it just that bit more interesting. The first thing we could do that's a core trope of a loading screen is changing up the point of focus. Let's create an array of sprites and a reference to our background image. Then, when the screen is enabled, we'll simply pick a random image from our array to display. Now, as much as we'd hate to admit it and keep loading times short, some hardware may end up taking quite a long time to load these scenes, so we might as well give people something to read while they're waiting. This is the perfect time to give tips to the player about your game. Let's create a pool of tips that we can slowly iterate through. We'll create a new TextMesh Pro field on our loading screen and set it up to hold our tip text. We'll also add a canvas group to it, as this will allow us to fade the text in and out. Then in our manager script, let's create a reference to our tips text field and also an array of strings for our tips. In Unity, let's assign the tips text and write out our tips. As soon as we enable the loading screen, we start a new coroutine called Generate Tip. Here, we'll assign a random tip from our list, and then while the loading screen is still active, we'll iterate through the tips. With just a little bit of extra work, we've created a much more interesting and more dynamic loading screen. You could maybe even go a bit further and have the screen transition in and out, or perhaps have it more interactable, but I think this is a great place for anyone to start. Now, I've mostly just covered loading and unloading of a scene in this video, but there may be more things you're doing in your game that could use a loading screen. For instance, if you're making a platformer or adventure game and the player dies, you might not need to completely reload the scene, but you might want to reset some things. That would be the perfect opportunity to throw up a loading screen while you clean up the scene. And again, if you know what you need cleaning up, you can give feedback to the player in much the same way. But that's about it from me for now. If you've enjoyed this video, be sure to give it a thumbs up and let me know what you think below. Hopefully there's some information in here that's helped you out or helped you think a bit more about the kind of loading screens you could create. Also, if